Today we're going to go ahead and solve right triangles, but sometimes when we solve right triangles, we actually have to find the angle of the triangle. And the way you find an angle is what's called the inverse of the trig function. So if we know that tangent of angle A is equal to x, then tangent inverse, so I'm just reading right here, so this is tangent inverse of x is the measure of angle A. So let's actually see how that works though, and that's the same with sine and cosine. But I want to go ahead and show how that works in problems like these. So remember, we're going to go ahead and use SOHCAHTOA, so this all still is the same. Probably getting sick of SOHCAHTOA. Oops, don't know what happened there. There we go. Okay, so the first thing you want to do in all of these problems that I gave you is to first figure out which of the trig ratios we want to use. So for number one, we have this angle right here. So the 18 is going to be our opposite side across from the angle, and the 45 is our hypotenuse. That tells us we're going to be using sine. So what I'm going to go ahead and do is I'll do sine of theta is equal to our opposite, 18 over 45. Then to go ahead and solve that, I'm going to just change this. So you're really just doing the inverse of both sides. So I'm just going to go theta is equal to sine inverse of 18 over 45. So notice what I did right here is I just moved this sign so that it had that little negative one that tells us we're doing the inverse, and we're putting it on the other side. So we're going to go ahead and type that in. On your calculator, the sine inverse button is right above the sine button. So you'll just hit second and then the sine button. 18 over 45. And that gives you that theta is equal to 23 point, and we're going to the 100th place, so 5/8. Approximately. Should put the approximate symbols there. Okay, same idea for the next one. So this one, we've got the opposite side from the angle and the adjacent side. So this time we're going to do tangent. So we have tangent of theta equals 9 over 29. And then I'll apply the inverse. So to move the tangent over, you do a little tangent inverse with that -1, and then 9 over 29. Same idea when you type it in. You're going to do second and then tangent, so they get that little inverse. 9 divided by 29, and theta is going to be approximately equal to 17.24. Just a reminder, make sure your calculator is in degrees or else your answer will be incorrect. I bet you can't guess what this one's going to be, but we're going to do the cosine one because this is our adjacent side, 19. And then the 23 is our hypotenuse. So we've got cosine. Let me switch back to blue because blue is a little easier to read. So cosine of cosine of theta of the angle equals 19 over 23. So to move that cosine over, so we just have theta, we do the little inverse. And then you type that in by doing second cosine inverse of 19 over 23. And that's approximately equal to 34.30. So same thing applies here, and I probably should have done this first, but that's okay. Same thing here, to move that sine over, to find h, you just do sine inverse of 0.2. And then you just go ahead and type that in. So h is approximately 11.54. So this one, h would be cosine inverse of 0.2. So we're approximating all of these. So this one, h would be approximately 78.46. And then our last one, tangent, so we'll do h is equal to tangent inverse of 0.2. So in this case, h would be approximately equal to 11.3. 0.31 degrees. And all of these I should have put degrees on every single one of these answers. Those are all degrees because we're finding angles. There you go.